In this video, you'll learn how to create and customize roofs in ideCAD. We'll cover hipped and gable roofs, adjust slope, eaves, and materials, and trim walls or create roof holes. You'll see how to add dormers, convert hipped roofs to gables, and even design vaults and domes. We'll also detail roofs with rafters, purlins, and hip rafters, and finish by placing and customizing gutters. By the end, you'll know how to model complete and professional roof systems in ideCAD. Let's start creating the roof. In this project, the top story also includes an attic space. Switch to the top story plan. There are two commands available for creating roofs in the ideCAD. The roof command automatically generates a hipped roof based on the defined outer boundaries. The roof plane command allows each roof surface to be defined individually. This enables different slopes to be assigned to each surface, offering greater flexibility and precise control over the roof geometry. The type of roof and the method used should be selected based on the specific requirements of the project. Click on the roof command to begin creating a hipped roof. Once the command is activated, the roof toolbar will appear at the top of the screen. This toolbar provides access to additional roof-related commands. There are also two input fields available on the roof toolbar. The first input defines the roof slope. The second input defines the eaves overhang, which is the portion of the roof that extends beyond the outer boundary. These values can be adjusted according to project requirements. Once the desired roof slope and eaves overhang are entered, the roof surfaces are prepared and ready to be drawn. Click the Settings icon from the Roof toolbar to open the Roof Settings dialog. In the General tab, the starting elevation of the roof above the slab can be specified. From the same section, parameters such as roof thickness, roof ID, eaves overhang, and eaves type can also be easily adjusted. In the Materials tab, the list of materials assigned to the roof can be found. Different materials can be selected for the upper, under, side, and detail material, allowing the roof to be represented more realistically in 3D views. In the Colors and Line Types tab, the roof's appearance in plan view can be adjusted. Here, settings such as color and line type can be customized to ensure that the roof and its details are displayed clearly and accurately in 2D drawings. Click the OK button to confirm the changes and close the Settings dialog. Let's define the roof boundaries. The roof boundaries are drawn in the same way as drawing a regular line. After defining the outer boundaries, the hipped roof is created. In some projects, certain walls may extend above the roof level. If these walls are intended to be trimmed below the roof, the Trim to Roof command is used. When the Trim to Roof command is clicked, a toolbar appears with several options: New Trim Group, Add Roof, Add Entity, Delete Group, and Trim Settings. Start by clicking New Trim Group, then select the roof that will be used as the trimming reference. Right-click to confirm the roof selection. Next, select the walls that need to be trimmed. This can be done in either the plan view or the perspective view, depending on which option provides better visibility and control for your workflow. This flexibility allows you to choose the method that best matches the complexity of the project and ensures that the trimming process is completed accurately. Once the walls are selected, right-click to confirm. The Roof Trim Settings dialog will appear. In this dialog, the trim group name can be renamed. You can choose whether the elements will be trimmed above or below the roof. You can specify whether library elements should also be trimmed. Color can be assigned to trimmed objects for easier identification. Click OK to finalize the trimming process. The selected walls will then be automatically trimmed to fit beneath the roof. When an opening needs to be created on a roof, the Roof Hole command is used. Let's create a roof hole for the terrace. Click on the Roof command. From the toolbar that appears, select the Roof Hole command. In the plan view, click to define the area where the hole will be created on the roof. By carefully selecting the boundary points, you can specify the exact size and location of the opening. This ensures that the roof hole aligns correctly with architectural elements such as stairs, terraces, or skylights and provides accurate integration in both the plan and 3D views. A roof piece can be created above a door or window opening using the dormer command. Click on the dormer command. Place the dormer in the desired area, typically referencing a wall. If the placement is not accurate, use the move command to reposition it. The default dormer may not have the required dimensions. To adjust its properties, double-click on the Place Dormer to open the Dormer Settings dialog. Various dormer types can be selected from this dialog: gabled, shed, hipped, round, and spline. Parameters such as width, depth, roof height, and sidewall height can be modified. Additionally, materials can be assigned to define the dormer's appearance in 3D. Let's adjust the materials by checking the Use Same Material option for the roof section. For this example, enter the following values: 180 centimeters for width, 300 centimeters for depth, 60 centimeters for roof height, and 50 centimeters for sidewall height. After entering the values, click OK to apply the changes and shape the dormer accordingly. If the sidewalls of the dormer are not needed, uncheck the Create Sidewalls option in the same settings dialog. This way, a simplified dormer consisting only of the roof surface is created. Click OK to apply the changes the dormer accordingly. Now, let's repeat the trim to roof operation, this time using the dormer as the reference surface. Click on the Trim to Roof command. From the toolbar that appears, select New Trim Group. Select the dormer to be used as the reference, then right-click to confirm. Select the walls to be trimmed, and right-click again to proceed. In the Roof Trim Settings dialog that opens, make the necessary selections and click OK to complete the operation. As a result of this operation, the walls intersecting with the dormer are automatically trimmed according to the roof slope and integrated with the roof. This ensures that openings, such as those leading to a terrace, are accurately formed. The dormer can also be used without trimming the walls. In this case, it functions purely as a visual element or as a source of natural light. Click on the dormer command again, then click the settings icon on the toolbar. Enter the following values in the dialog: 180 centimeters for width, 300 centimeters for depth, 60 centimeters for roof height, and 50 centimeters for sidewall height. Ensure that the Create Sidewalls option is checked. Click OK to close the dialog. The dormer is then placed in the desired position. Check the Use Same Material option for the roof section from the dormer settings. If needed, a door or window can also be placed on the dormer. We previously mentioned the Roof Plane command as an alternative to the standard roof tool. Now, let's use it to create a gable roof. Click on the Roof Plane command. When the roof toolbar appears, the slope and eaves overhang values can be entered in the corresponding value boxes. The slope direction of the roof surface is defined. This determines the direction in which the roof will slope and where the gutter will be placed. Next, the boundary line of the roof plane is drawn to complete the first section. To edit the created roof surface, double-click on it and the Roof Plane Settings dialog will be opened automatically. From this dialog, you can adjust the ID, elevation, thickness, color, line type, and slope. Under the Materials tab, materials can be assigned for the upper, under, side, and detail materials. For this example, check the Single Material option and then select the material named Roof Tile from the material list. In the Detail tab, visual settings such as drawing color and line type for the plan view can be configured. By clicking the OK button, the first part of the gable roof is completed. To create the second surface of the gable roof, select the first roof surface. Click the Mirror command. Define the mirror axis, which should run along the ridge line of the gable roof. Once the mirror axis is set, ideCAD automatically generates the second roof surface, completing the gable roof configuration. In ideCAD, hipped roofs created using the Roof command can optionally be converted into gable roofs. To perform this conversion, follow the steps below. First, create a hipped roof with 4 sloped surfaces using the Roof command. By default, The roof will be generated with slopes on all 4 sides. Click on the Change Roof Edge Properties command under the Roof section. Select the roof edge where the slope is to be removed. In the dialog that appears, set the slope angle to 90 degrees to make the edge vertical. Uncheck the Create in 3D option to prevent a roof surface from being generated on that edge. Click the OK button and repeat the same process for the opposite edge to complete the conversion to a gable roof. The sloped surfaces on 2 sides are removed, and the hipped roof is converted into a gable roof. ideCAD allows both vault and dome to be created. To create a vault, a reference curve must first be defined to guide the slope of the vault. From the Drawings tab under the Primitives section, use the Arc through 3 points command to draw the reference curve. From the Home tab, click the Vault command. Select the reference curve and right-click to confirm the selection. Since free placement is preferred in this example, right-click again without selecting any alignment path. Alternatively, a line or path can be selected as a reference for alignment. Define the start and end points of the vault, similar to how a wall is drawn. Right-click to complete the vault placement. Double-click on the placed vault to open the Vault Settings dialog. In this dialog, parameters such as ID, chord count, elevation, thickness, eave type, and material assignments can be modified according to the design requirements. Let's create a dome. Click on the Dome command. The dome height can be adjusted from the value box located in the toolbar. Left-click to define the center point of the dome. A dome preview will appear, and its size will change as you move the mouse. Left-click again to finalize the size. The dome will be created upon clicking. Double-click the dome to open its settings. In this dialog, parameters such as radius, elevation, height, thickness, ID, eave type, and the number of horizontal and vertical segments can be modified as required. In ideCAD, roof elements such as rafters, purlins, and hip valley rafters can be easily applied to the roofs that are created. To better view the details, let's raise the roof elevation slightly. For example, by setting the elevation to 500 centimeters, the elements located below the roof are displayed more clearly. From the Roof Details section, click on the Rafter command. Select the roof to which the rafters will be applied. A preview of the rafters will appear based on the default settings. In the Rafter dialog, you can adjust the count, spacing, width, height, and starting point of the rafters. If rafters are to be applied to all eaves, check the Apply to All Edges option. Once the necessary adjustments are made, click OK to generate the rafters. Let's continue with defining roof details by adding purlins. Select the Purlin command. Then click on the roof surface where the detail will be applied. The program automatically places a purlin on the selected roof surface and displays a preview in both the perspective view and the plan view. From the Purlin dialog, you can adjust the width, height, distance, and elevation. If desired, you can check the Apply to All Edges option to apply the purlin to all roof surfaces. All changes are instantly reflected in both the plan and 3D views. Once the settings are complete, click OK to place the first purlin. To create a second purlin, run the command again and enter the new values. Next, we'll place a hip valley rafter as part of the roof detailing process. Click on the Hip Valley Rafter command. Move the cursor to the intersection point of the roof surfaces and left-click to place the ridge. From the Hip Valley Rafter dialog, you can adjust the width, height, and elevation of the Hip Valley Rafter. After making the necessary adjustments, click OK. The Hip Valley Rafter will be created automatically. In this way, all Hip Valley Rafter details in the roof system can be defined step by step. With this method, roof details such as laths, fascia boards, posts, struts, collar beams, and trimmers can also be added step by step to complete the roof system. Let me point out an important consideration when adding roof details. For roofs that were initially created with the roof command and later converted into a gable roof, the apply to all edges option should not be used. When the rafter command is clicked, the roof is selected, and the apply to all edges option is checked, rafters are attempted to be placed by ideCAD on all roof surfaces, including those that are not visible in the model. Since these surfaces are still defined in the background, rafters may become visible in the 3D model. However, since these hidden surfaces cannot be correctly represented in sections or elevations, the rafters placed on them may not be properly reflected in the drawings. To avoid such issues, when working with roofs that have been converted into gable roofs, the Apply to All Edges option should be disabled while adding roof details. Instead, each relevant eave surface should be selected individually. This way, the details are applied only to valid surfaces, ensuring that no errors occur in sections or elevations. The roof is now lowered back to its original elevation, level 0, and a gutter will be defined. Click on the Roof Gutter command located in the Facade tab. This command allows gutters to be placed automatically on roof surfaces created with the roof command. As soon as the command is activated, the program automatically detects the roof and displays a preview along its edges. The gutter settings can be accessed either by double-clicking on the gutter after it has been placed or by clicking the settings icon on the toolbar before placement. Left-click to place the gutter. Double-click on the gutter to open its settings dialog. From this dialog, different gutter types can be selected. Additionally, the drawing color, line type, elevation relative to the roof eave, and the material for 3D visualization can be adjusted. If a manual approach is preferred, gutters can also be defined using profile objects, which allow you to create a fully customized gutter. With the addition of the roof gutter, the roof creation step has been completed. Thanks for watching. Don't forget to like, subscribe, and explore the knowledge base for more tips. See you in the following video.